Hello guys, good afternoon. Welcome to the today online class. I am Dr. Suresh Babu. Okay, see, as in today, we came to know the topics which are studied under module number 1. So now we are entering into the module number 2. Under module number 2, see, we have completed hydraulics formula which are used for the determination of velocity and the discharge. See, both we are came to know, okay, from module number 2. That is, and in the last class, we are talking about, discussed about, what do you call, velocities. Those velocities are nothing but what you call self-cleansing velocities and non-scoring velocity. There are two types of velocities you have to consider. One is the minimum velocity, another is the maximum velocity. Minimum velocity when it is required. Do you know the minimum velocity when it is required? The minimum velocity is nothing but self-cleansing velocity and maximum velocity is nothing but a non-covering velocity. See, if you are not maintaining properly the minimum velocity, then what happens? The solids which are present in the sewage, they are going to settle. After settlement, the diameter automatically reduces. The increasing in the depth of what you call the silt, which is going to be deposited. Automatically, there will be a problem that water will start moving backwards. Okay, then it is a very big problem for cleaning and maintenance, etc. Okay, see, that is why the minimum velocity of flow is to be required to push these particles and look into the matter particularly. ನೋಡಿ, ಯಾವುದೇ ಥರನಾದ ಸಾಲಿಡ್ಸ್ ಡಿಪಾಸಿಟ್ ಆಗಲಿಕ್ಕೆ ಬಿಡಬಾರ್ದು. ದಟ್ ಈಸ್ ವೆಲಾಸಿಟಿ ಮೀನ್ಸ್ ಡಿಸ್ಟೆನ್ಸ್ ಟ್ರಾವೆಲ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಟೈಮ್ ಟಿ. ಓಕೆ, ಸಿ ದಟ್ ಈಸ್ ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್. Now this velocity is the minimum velocity you have to maintain. Next one is what you call maximum velocity, means you should not be more than the required velocity. The velocity we are having two types already discussed. The non-coverings. Covering means what happens? The particles are silt or whatever the substances which are present inside this what you call that sewage. It should not damage the internal surface. That is very, very important. Otherwise, once it is damaged, it starts. Internal surface is a very smooth surface and nice surface. These particles, due to high velocity, what happens? It will damage the internal surface. Internal surface damage ಆದ ತಕ್ಷಣ ಏನಾಗುತ್ತೆ? ಸ್ಮಾಲ್ ಕ್ರ್ಯಾಕ್ಸ್ ಅಂಡ್ ನೆಕ್ಸ್ಟ್ ಸ್ಲೋಲಿ ಕ್ರ್ಯಾಕ್ಸ್ ಅಂತ ಕರೆಯಲ್ಲ, ಅದಕ್ಕೆ ಏನಂತ ಕರೀತಾರೆ? ಸ್ಮಾಲ್ ಪಿಟ್ಸ್ ಅಂತ ಕರೀತಾರೆ, ಪಾಟ್ ಹೋಲ್ಸ್ ಟೈಪ್. ಓಕೆ, ಆಮೇಲೆ ನೆಕ್ಸ್ಟ್ ಏನಾಗುತ್ತೆ? ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ 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 ದಟ್ the depth or hole will be formed. And what happens? See, the non-scoring velocity means internal surface will becomes rougher and rough. Okay, rough ಆಗ್ತಾ ಬರ್ತದೆ ರೀ. ಅದು ರಫ್ ಆದರೆ ಫ್ಲೋ ಕ್ಯಾನಾಟ್ ಬಿ ಮೇಂಟೈನ್ ಪ್ರಾಪರ್ಲಿ. ದಟ್ ಈಸ್ ಆಲ್ಸೋ ಎ ಪ್ರಾಬ್ಲಮ್ ಫಾರ್ ಯು. ಫ್ರಿಕ್ಷನ್ ಕೋಫಿಷಿಯಂಟ್ ಅಂತೇಳಿ ನೀವು ನೋಡಿದ್ದೀರಾ ಆಲ್ರೆಡಿ. ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಇನ್ ಹೈಡ್ರಾಲಿಕ್ಸ್ ಲ್ಯಾಬ್ರೋಟರಿ ಯು ಆರ್ ಸ್ಟಡಿಡ್ ಫ್ರಿಕ್ಷನಲ್ ಕೋಫಿಷಿಯಂಟ್ ಥ್ರೂ ಪೈಪ್ಸ್ ಅಂತೇಳಿ, ಫ್ರಿಕ್ಷನ್ ಥ್ರೂ ಪೈಪ್ಸ್ ಅಂತ ಎಕ್ಸ್ಪೆರಿಮೆಂಟು ಮಾಡಿದ್ದೀರಾ ಅಲ್ವಾ? ಸಿ ದೆನ್ ದ ಹೆಡ್ ಲಾಸ್, ದೆನ್ ಆಟೋಮೆಟಿಕಲಿ ಹೆಡ್ ಲಾಸ್ ಮೀನ್ಸ್ there is the chances of leakage of water from the joints. Okay, now the topic number 1 you know, topic number 2 also know. The theoretical formulas we came to know how to determine the velocity. Okay, next is we are coming today, what we are going to study today is design of sewers, the third topic. See, just to go through class number 11, you can see the syllabus, how much I have to cover in this module. Okay, you can see everything. Now, design of sewers means, what is the meaning of design of sewers? Now, this one is design of sewers means, here velocity is one of the important factor. If velocity is not given, how to determine? If Q is not given, then how to determine? See, that we can see in this topic. Okay, now let us start with one problem. See, here this problem will be the actually the given and is very important, and usually in the examination from the module number 2 you can get minimum 2 to 3 problems, that is design problems. Please be careful. In module number 1 also problems and module number 2 also problems. Now almost all modules, 5 modules whatever you are having, see that numerical problems minimum what you call 2 to 3 problems will be going to ask in the main examination. In the VTU external examination I am telling. Okay, please see that and listen properly. This, what is this design? Design of sievers means, what is the meaning of this? We want a diameter. To find out the diameter, Q is equal to what? AV. What is A? Pi d square by 4. It is a circular in diameter. Remember, circular section it is. Only you have to know Q and V. If you know these two, then it will becomes very easy to determine the diameter. Let us see what is this problem. Okay. See, calculate, I will read this one. Calculate the velocity of flow in a sewer of diameter 120 centimeter. See, 120 centimeter diameter means 1.2 meter diameter of the pipeline. See, calculate the velocity of flow. Okay. Then the sewer is laid to a gradient of 1 in 400. See, 1 is to 400, that is a gradient, it means slope. Then what would be the discharge through this sewer when running 1 of full? Assume n is equal to this much, 0.012 in Manning's formula. This is a very clearly they are given this problem. Okay, try to understand what it is and all. Okay, if you are in really the language of English, understanding the sentences, how to solve the problem, it will becomes very easy. So before starting any problems, you have to write what are the given values, what are the given values in problem, and what is going to ask. See, okay. Now here, calculate the velocity of flow means velocity you have to find out. Number 1. Okay. Next, they are given some data. Afterwards, what would be the discharge? Then Q also you have to determine. See, now velocity also you have to determine, Q also determine when the pipeline is running 1 of full. You remember it. I am going to explain what is this 1 of full. 1 of means what actually? 1 of. See, there is a diameter. That pipe is having what you call diameter and radius. Radius is 2. Okay. 2r is equal to 1 diameter. Now, 1 of full means how much? How many offs off? That means 50% are in one pipeline, in a circle. How many offs are there? 2 off. Okay. Out of the 2 off, 1 off full means it is a 50%. That is off flow. Because in your syllabus, there are 2 conditions. One is a full flow. When the sewer is running full flow, what will be the design? And then when the, that is what you call, when the sewer is running with off flow, then how to determine? Off of the pipeline only it is flowing. Remember it. Now with respect to off flow, you have to design the pipeline. Okay. Now let us start with this. Now in this case, they are given one small clue. See, that is a assume, what you call? See, assume, they are given, assume it is here. Okay. N is equal to 0.012 in Manning's formula. We are knowing that Manning's formula. Remember it. See, they are given the clue, use Manning's formula, find out the velocity. After getting the velocity, you go for the Q value. So Q should be running, that means velocity as well as Q is running off full. That is off flow they are given. Very neatly they are mentioned. Okay. Now, you just write down what are the values given. Velocity is not known. Diameter of the sewer we know. That means they are given. And the gradient means the slope of the sewer. It is 1 in 400. 1 in 400 means h by L. L is the distance, h is the height. That means 1 by 400. Then Q is equal to how much? What will be the discharge they are given? That is why the Q is equal to question mark. What will be the